I'm Andrew Vreugdenhil. I'm a professor in the Department of Chemistry and the Materials Science Graduate Program. We've been working with carbonics for the past 7 or 8 years. We are primarily responsible for supporting them in their research and development of novel materials. They work in carbon materials, and so we've done a lot of process design of materials, characterization of materials, and so on, using the facilities that we have available to us here at the university. We're finally now at the stage where we've been able to generate some very, very useful materials and produce intellectual property that has some value. So as a result, over the last year, we've been working steadily with carbonics to protect that intellectual property in the form of patents. In our patents, the patents belong to the company, but myself and my students and my staff members are listed as inventors on those patents. So it represents an important accomplishment professionally for all of us. It's been really great collaborating with carbonics throughout my research career here at Trent, and even previous to that, I've always collaborated with industrial partners. It's been a really important part of the joy I get out of working in science and applications-oriented research. We're very enthusiastic, of course, about using and developing and understanding carbon-based materials, and particularly activated carbon, for the many interesting challenges that it presents to us and the ways in which we can apply it both sort of academically and commercially. So we love working with and solving these problems. But at the same time, it's also very rewarding to collaborate with an industrial partner so that we get to also have an avenue where that material can escape the lab, where it can have a life beyond just our investigation and understanding and publication of that. And I think for my team, for the students and staff members and myself, we enjoy both aspects of that. Doing the fundamental academic studies, of course, which underlays the development of these materials, but then also being able to not just see them become commercialized and developed outside of the lab in an industrial context, but also to really play an active role in getting that there. Appreciating that there are many, many questions that need to be answered after we think we've fully understood, the system itself. But how can it be done in a sustainable way? How can it be done in a commercially viable way? Is an equally interesting challenge, I think, for all of us. And so speaking for the grad students on my team, for example, I think that they really enjoy knowing that these materials aren't just something we're studying for the sheer joy of studying the material, but instead also looking at these materials and being able to think about the fact that they will be used commercially to, minimize an environmental footprint from a particular industry, or even just divert something that would otherwise, go into a landfill. And I think that can also be a really rewarding outcome for people who are studying an area like this.